Welcome to Essentially Only, the most successful essential oil and essence company in the Houston area. After 10 years of creating oils that take care of our customers, we want to make sure we're creating products that care for the world too. And to do this, we had a team of expert engineers from the UH engineering department to help us monitor our essentially only waste. And hopefully, after hearing their presentation, we at Essentially Only will be able to reduce our environmental footprint.
Hi, I'm Christina.
I'm Gabby.
I'm Monica.
We are the team of expert engineers that essentially only hire to determine the amount of waste product in their oil refinement process. We're hoping that after our explanation, essentially only will have a full understanding of their process and be well on their way of making responsible choices to reduce their environmental impact. So, let's get started.
What's the problem? So first we have to look at the steam distillation process and figure out what exactly we're trying to find out. After observations, we discovered that we need to calculate the weight of solid plant material in the waste stream after 500 kilograms per hour of dry plant material and 500 kilograms per hour of steam are placed in the boiler.
Next, we needed to figure out what we do know about the steam distillation process in order to get ourselves organized and have a better understanding of our problem. What we do know is that the input is 500 kg per hour of steam and 500 kg per hour of dry plant material. 65% of the weight of the product stream is steam and 35% of the weight is oil. 98% of the moles of the product stream are steam and 2% of the moles are oil. The product flows out at a rate of 25,000 moles per hour, and the molecular weight of water is 0.018 kg per mole. We assume that the product stream acts as desired, there's no reaction, it's a steady state. Any excess product is added to the waste stream and include excess oil as solid plant material.
After finding all of that information, we can then find a solution. Using the general balance equation, we know that input plus generation minus output minus consumption equals accumulation. And from our assumptions, since we know that it's a steady state and that there's no reaction going on, that generation, consumption, and accumulation are all equal to zero. When we rearrange the formula, that means that input equals output. We also know about the certain ratios that should happen in the product stream. The product stream, which we'll call M3, should consist of 65% water and 35% oil by weight. The waste stream, which we can call M4, should consist of wastewater, the variable W, plus solid plant material P. The waste stream should also equal to the input of 500 kilograms per hour of steam minus the product output of water, plus the 500 kilograms per hour of plant material minus the product output of oil. Using all these formulas, we can solve for x to get the weight of the solid plant material waste. Additionally, here's our flowchart that has labels for each of the streams that go in and out. M1 is the input of 500 kilograms per hour dry plant material. M2 is 500 kilograms per hour of steam. Each of these are the input. Outside of the boiler, we have M3, the weight of the total product stream, as well as N3, which is the total mole output of the product stream that we know from the given in the problem. And we have M4, which is the weight of the total waste stream. Also, next to N3 and M3, we have the proportions of steam and oil inside of the stream.
For the degrees of freedom, we have three unknowns: m.3, which is the weight of total product stream, p, which is plant waste, w, which is water waste. To find 0 degrees of freedom, you would take m.3, p, and w minus 2 independent species minus 1 physical property. The equations are m.1 plus m.2 equals m.3 plus m.4. To find p, m.1 equals x m.3 plus x m.4. To find w, m.2 equals 1 minus x m.3 plus 1 minus x m.4. And finally, 1 mole of water equals 0.018 kg of water.
And with all of that taken care of, we can go on to refinement and implementation, and finally calculate how much solid plant material there is left in the waste stream. So first, we know N, which is the product stream coming out in moles per hour, which is 25,000 moles per hour. 98% of this is water, and 2% of this is oil. As you can see here, we can multiply 0.98 times N to get each of the components of the product stream. After that, we can figure out the weight of the produced water, knowing the mole conversion of water, which would be 24,500 moles per hour of steam times 0.018 kilograms per mole, which leaves us with 441 kilograms per hour of water. This is also equal to 0.65 m3 because 65% of the weight of the product stream is water. Using this, we can figure out the weight of the entire product stream, which is 678.5 kilograms per hour. We can also find the weight of the oil in the product stream by subtracting the total weight of the product stream minus the weight of water, which gives us 237.5 kilograms per hour of oil. Now we know that the plant material is equal to the input of the dry plant material minus the weight of the oil. That means that the leftover plant material is 500 minus 237.5, which leaves us with a total waste of 262.5 kilograms per hour of solid plant material.
So finally, we need to verify and test. And to make sure our numbers were correct, we verified our results using our Excel spreadsheet.
Wow. Thank you so much for this. We had no idea that we were creating that much waste every time we made our products. Thanks to you, now we can address this issue and think of possible ways in which we can limit our waste. For example, we could alter our processes or even recycle the waste for use in other projects. Hopefully, by taking this step, our company can become an example for others, reminding us all of the importance of knowing just as much about the waste we produce as the product itself. After all, if it weren't for our environment, essentially only, and so many other brands, wouldn't be here today, so it's up to us to try and protect it for future generations.